Agreed? What else?
Inputs and outputs switch.
Inputs and outputs switcheroo? Yeah, for sure. Anything else? Anything else you can think of as far as properties?
The inverse of an inverse equals the original.
Okay, so the inverses undo each other? Okay, so the composition is where I'm going with this. So if you take a function and its inverse and you compose it either way, you get x, right? And so, like when you're saying the inverse undoes the, its original function, they undo each other. The only thing left would be the input, aka x. Okay, so those principles are pretty important here. So again, hopefully you did watch the intro video or you remember this. So a couple things, I think, just housekeeping things as far as to make this a little bit easier. This gives us this lovely function f of x, and then it says find the derivative of. When you read that out loud or when you say it in your head, don't say f to the negative 1 because that's not what that means. It means the inverse of f. Okay. So I know I told my classes this last year, I'm not really a big fan of the whole f with the little -1 notation. It gets a little confusing, and here's an example of where it's confusing. If I was going to do the derivative of this, wouldn't the derivative of that look like this? Inverse of f prime.
It looks whack.
And there's just a lot of little symbols going on, and it's easy to get them mixed around. And then when you look at what this actually is equal to, it's that. And see, maybe you can see why this, I'm not a fan of this notation. There's too many little tick marks and minuses and things that look like ones, and it'd be super easy to get it confused. So can I propose a better way? All right. So here it is. I think if you're ever presented with something like this, I would redefine the inverse of f and say, I don't really like that notation. I'm going to call the inverse of f something else. I'm just going to call it g or h or some other function, something besides f, right? Some other function besides f. And once you arrive at this, and you do want to write this down, this is not like a universal, everybody does it this way. I mean, a lot of people do, but it's not universal. So you want to write this down and say, from here on out, instead of writing inverse of f, I'm going to write g. They mean the same thing. So if that's the case, aren't I really looking for g prime? Okay, so here, again, from the video perhaps, let me actually clean this up a little bit. So if I'm looking for g prime of x, the way you do it is you find 1 over f prime of g of x. And I just think that looks cleaner than all the little -1s everywhere and primes and easily mixed up things. This comes straight out of the chain rule. If you just multiply both sides by that denominator, you'd get the chain rule version of that composition leading to x. And again, if it sounds like I'm speaking a foreign language, watch the intro video. It's fairly well presented there. Okay, so this to me would be a good starting point for any effort involving derivatives of inverse functions. So if you memorize that, awesome. If you watch the video and you're like, I think I would like to develop that every time, you can do that too. But I bet you if you developed it a few times, you'd probably just remember it. So anyhow, so let me just run with you through one of these real quick, and then I'll let you guys try the other ones just to make sure that we're all in good shape here. So I've got g prime of 7 is what I'm trying to find. So g prime of 7 then would be 1 over f prime of g of 7. And so in these situations, I guess in this one you could actually do this. In these situations, often it's going to be impossible to actually find the explicit version of the inverse. You actually could here with number 2. Switch the input and output and solve for y, right? You could do that here, but I want to train you on what you'll need to do like on number 3. So g of 7, as it stands, we do not have a function for g. Okay, right? There just isn't one. And so you can do, you could solve for it in this case, but like I said, number 3 and 4 and a lot of other ones you can't. Here's how we handle this, finding g of 7. Isn't 7 the input for g? And you all said it a few minutes ago that with inverse functions, the inputs and the outputs do what? So if 7 is the input for g, wouldn't that be the same as the for f, right? It'd be the output for f. So instead of hunting around for some g function or trying to find the g function, what I'm going to do is come up here and say, well, I think I want to set 7 equal to the output of f. Because again, I know that the input and the output with inverse functions get switched. This is a pretty easy equation to solve. Can anybody just like by inspection tell us what the answer is?
1.
X is 1. And so that by inspection is going to be a key thing. We're going to need to do a little arithmetic in our head on some of these. But I would hope that we've given some fairly small integers, that would be doable. Okay, so then I would say this is now equal to 1 over f prime of 1, because we just found that g of 7 is 1. And then the only thing I got to do now is find f prime and plug in a 1. So what do you think that would result in? 6. So the final answer here would be 1 over 6. Okay. So that all sounds good when we do it together. Do you have any questions, though? So if you personally don't have any questions, why don't you move on to, I think it's 3 and 4. I can't remember if there's a 5 or not, but check out numbers 3 and 4. With those two questions, they'll be a little bit harder on some of the mechanics of finding the inverse of the input, but I bet you can do it. And if you can't, we'll get it figured out together.
Can you tell me how you got to 6 real quick?
Sure. So we're supposed to do f prime of 1 for this denominator.
So it'd be...
So what I did is I found f prime, and f prime is 6x squared,
Yeah.
and then I plugged in a 1.
Oh, that's right. Okay, I got you.
And then I just dropped that in the denominator, and we're good. Any other questions or clarifications I can give for you on number 2?
Can we use a calculator for number 3?
So with these, calculators are pretty much never allowed. So I'm going to say no on the calculator.
That's cool.
Compare. I think we're all in at least a decent place here. We want to clearly define that we're talking about inverse of f being represented by g. If I'm trying to find g prime of negative 15, then it would look like this. So then negative 15 is the input for g, which also means that it could also be the...
Output for f.
Oh, well said, Jack. So negative 15 equals 2x cubed plus x plus 3. This is where you commence with the guessing and checking. Did you all get negative 2 for x?
Logan did, yes.
Okay.
Shut up.
So this means that we're really trying to find 1 over f prime of negative 2. And f prime is what? 6x squared plus 1. So did you guys get 25 for that?
Yep.
So 1/25th?
Yep.
Yeah,
Okay.
that's good. That's nice right there. That's good.
Okay.
Or
And-
some would say 0.04.
0.04 works. Okay, so then for number 4, g prime of 0 would equal 1 over f prime of g of 0. And so we do the same thing. 0 equals 2x to the 5th plus 4x minus 6. And according to Peyton, this is the easiest one. She said that's the easiest one to guess, right? You plug in a 1, right? And it ends up being 6 minus 6. So 1 over f prime of 1. So let's see here. F prime is 10x to the 4th plus 4. So that'd be 14, wouldn't it? So 1/14. There's that 1/14 that we were just asking about.
Well, no, I was
There
just
we
making
go.
fun of Logan because he said it didn't equal g prime. He just wrote 1/14 and then boxed it.
Now that's not very good, is it? As far as notation and communication goes. I agree. Good deal. So you guys have follow-up questions. This is a pretty straightforward lesson. We're not gonna really deviate too much from this in regard to these. Y'all good?
Say we got like 2x squared.
Plus 4. And then we would have to, that would be f, right?
Well, so the hard part about 2x squared plus 4 is the inverse of that is not a function because 2x squared plus 4 is not 1-to-1. So in order for a function to have...
Let's do 2x squared minus 4.
No, the squared is what messes it up. And really, the 4x to the 0 does 2. So like if you try to do the guessing thing and there's like 2 possible numbers or even 3 possible numbers, it means that it's not a 1-to-1 function. And so the inverse isn't a function either. So I and other test writers have to be careful to give you 1-to-1 functions in this situation.
Big job.
Oh, don't want to mess that one up. Could be confusing, right? Especially for the grader. Anyways, does it make sense? Did I answer your question? Okay. Guys, are there any other questions I can help you with on inverse functions? All right, fair enough. Let me hand your test back to you from last time, and we will... The x is indeed e to the x, but then the question has to come up, well, what if it was more than just e to the x? What if the exponent was a little more complicated? Like what if it was e to the cosine of x, or e to the x squared minus 9x plus 10? What rule applies now? Chain rule is going to show up. That chain rule factor will be there. So what would you guys guess the ddx of e to the u would be?
U prime.
Like you'd have an extra factor of u prime, right? So it'd be e to the u times u prime, or e to the u times du dx, right? Same thing. And so, hopefully this is the easiest derivative to remember, maybe for the whole year, right? The derivative of e to the x is just e to the x. And of course, soon we'll find out that the antiderivative of e to the x would then have to be e to the x plus c. So it does depend on what the c is. It might be e to the x plus 9. You never know. Okay, so if you would, please take a look at numbers 1 and 2. See if you can apply those couple of rules there involving e. I guess there is a third one now that I'm... just do 1 or 2. Just do 1 or 2.
That'd be a cool
Yeah, some of these graphs get pretty interesting. It's fun to get on Desmos and try to create graphs for you guys on your notes and quizzes and tests and stuff. You get pretty creative sometimes.
Desmos is kind of sick.
It's awesome. Yes.
It's lit.
Pretty impressive, but.
It really is. Yeah, I mean, you can type in even some pretty suspect syntax, right? Just some like pretty ugly math, and it'll interpret it right. And it's very, very cool stuff.
I don't like the way my number is.
I don't like the way any of my handwriting looks.
You don't like how your handwriting looks?
No.
My handwriting.
I can't even read my handwriting sometimes.
My
Well, I
handwriting
understand why your zeros have like an open
I
part.
just don't finish it.
My zeros look sometimes like 6s. I've lost
I
one
hate
sometimes.
those.
Yeah.
That's a pet peeve, zeros that look like sixes.
My 5s look like S's sometimes, my 2s and Z's.
Oh, what if would you round the corners on 5? I love that.
You gotta go.
You know something crazy?
Anders,
When I was
do you
in
remember last year when Santi had his zero that looked like a C? Like, just like the letter C.
Yeah.
And he argued for like 10 minutes. It was more like 5. But he argued for like 5 minutes that it was a zero, not a C, because like there's no C's in the rest of the problem.
Yeah.
It's like it looks so much like a
It's just a C.
C.
Yeah, I think
looked
I
at
do
it
remember
and it was so bad.
When I was in like first
Yeah.
grade, I saw somebody writing a 2 with the little circle. Like that. Sorry, Bill.
Oh, the loop?
The little loop 2.
Yeah.
Hey,
I saw somebody do that like in first grade. I was like, that looks really cool. So I started doing it.
stuff from first grade?
Wait, you remember stuff from like before?
I remember stuff from first
The
grade.
before times.
I absolutely can think of first grade. Yeah, I can. Yeah.
I don't remember my teacher's name, but all I know is that she didn't like me. But I was
All my teachers from elementary school hated my handwriting. They always said like get better handwriting, and it still needs to get better.
One of my favorite memories from first grade. So my teacher in first grade was coincidentally named Mrs. Anderson.
Wow.
Total coincidence. I remember it was reading time, and we were sitting in those, those like orange and blue and yellow plastic chairs, like
Oh,
little
yeah.
kid chairs,
Yeah.
We were sitting in these chairs in a circle, and I remember one of my friends, I don't remember his name, but I just remember he says this, like, he's squirming around, and he raises his hand, he's like, Mrs. Anderson, I gotta go pee, can I go? Oh, it's too late. And he was like going. That's one of my first grade memories, this poor guy just like peed his pants right in the middle of reading group.
I remember there's this
Stark
kid named
memory.
Ben, and Ben was like awful. I hated Ben, but mostly because he was just like really weird, and I didn't really understand like what he meant and like why he was doing it. And one day he came into class. It was like really early, first day of class, and he looks and he just like walks in, and he's like, It's almost my birthday. And then I'm just sitting in my chair and I look over and I'm like, dude, nobody cares.
Oh, we're back to nobody asked. I was going to say, isn't that the phrase? Nobody asked. What do you guys think of? What do you guys think of number 1? Y'all okay with number 1? E to the 8x cubed minus 2 times 24x squared.
Yeah.
Does that work okay?
That looks real good.
Did you guys do a
I
quick?
did skip 3rd grade because after that we realized.
Did you guys all do a quick rewrite on 2?
Yeah.
So how did you decide to rewrite 2 to make it easier?
Negative 5x to the negative 2.
There we go. Okay, so I think you really want to do that, right? And then when you try to find out your derivative, we'd say h prime equals, it would be just e to the u, and then the derivative of the inside is 10x to the negative 3rd. So we'd multiply by that, and we got those first 2. So just kind of some fairly straightforward applications of the derivative for e. Any questions? Okay, so number 3 is an extrema question. Is it absolute or no? It's local. So why don't you guys take a minute, look at number 3. It says find all local extrema for that function. So give it a shot. It's on screen almost. There we go. It looks so innocent and simple, but maybe it's not. Okay. All right, so here we go. Local extrema. I want you to, before you just blurt, listen please, before you just blurt out an answer, which you may or may not tend to do, but before you think, just like blurt, think. What are the candidates for local extrema?
It's critical numbers. That's it.
Just critical numbers, right? Just looking for critical points or critical numbers only. Critical numbers are where f prime does what? So let's find f prime and analyze that. So f prime of x, did y'all do a product rule?
Yes.
So x e to the x plus e to the x equals 0. I know this looks like a hard equation to solve. If you factored out the e to the x, it got easier. So e to the x parentheses x plus 1 equals 0. And so then x plus 1 could equal 0. And then you could say e to the x equals 0. But the truth is e to the x can never equal 0. So that's not going to produce any solution. So we can ignore that safely. And we just go with the only solution from that factor, x equals -1. You know what? It didn't say justify your answer, but let's do that anyways so that we can get a little practice with that. You could do a number line. What would this number line be in regard to? What function, what equation?
F of x. Oh, wait, no. F prime of x.
I don't think so.
F prime of x.
I think it would be f prime. If I'm looking for local extrema, I want to test the first derivative. So I'm going to test out f prime.
I said F of x.
So we have to.
You were getting ready to correct yourself. Yeah. All right. So what number to the left could we try?
0.
To the left.
Let's bring that one.
There we go. F prime of -2. I know this seems, listen, I know this seems like this would be really difficult, but don't you get -2 e to the -2 plus e to the -2?
So it's just negative. So it's just
Negative e.
negative.
No.
To the -2.
Yeah, it's just -1 e to the -2.
That took so much out.
And here's, hey, listen, don't miss this reasoning. This is good reasoning. If e is positive, then e to the -2 would have to be positive, because all you're doing is flipping it down and squaring. So the negative of that would have to be negative. So over there we have a negative, and then over here, hey, what can we plug in on the right of -1? 0. There's a good one. So if I plug in a 0, I get f prime of 0 equals 0 times e to the 0 plus e to the 0, which is equal to 0 plus 0 plus 1, which is 1, clearly a positive number. So you can for sure now confirm that at x equals -1, we do have a local extrema. In fact, specifically what kind? Minimum. So you could say f has a local min at x equals -1 because f prime of -1 equals 0, and f prime does what?
Changes from negative to positive.
There we go.
I want you to have fun.
All right.
Have you had a good day?
Any follow-ups, any questions, anything I can do to help you? It's a nice tie back to our very first unit of the year, chapter 3 is what it was. All right, so you can all see that when I see you guys next week, we'll be talking about antiderivatives. But for now, let's close it up. Hope you have a great weekend.